Chapter number 6, Mechanical Properties of Solid. Today we discuss the types of trace. In previous lecture, we defined the quantity trace. Trace is defined as the internal restoring force per unit area is called trace. Okay. Trace are of different types, or we discuss the type of trace. There is three different types of trace. First one is called tensile or compressive trace. Tensile or compressive trace. If we apply the force on any body, then deformation takes place, and due to deformation there is change in length, change in volume, and change in shape of the body. In tensile, or it is also called longitudinal, tensile, longitudinal or compressive trace, due to applied force, there is change in length of the body. ज्यावेळेस आपण एखाद्या बॉडीवर फोर्स अप्लाय करतो त्यावेळेस त्या बॉडीचं डिफॉर्मेशन होतं म्हणजे त्या बॉडीच्या लेंथमध्ये, साईजमध्ये, आकारामध्ये बदल होतो, त्याला आपण डिफॉर्मेशन म्हटलंय. आणि जर अप्लाइड फोर्समुळं त्या बॉडीच्या लेंथमध्ये चेंज झाला तर त्या ट्रेसला म्हणायचं टेन्साईल, लॉन्जिट्युडिनल or compressive trace. Due to applied force, there is change in length of the body. Such trace is called tensile trace. Therefore, tensile trace is equal to force per unit area. This is the formula of tensile force. In tensile force, there is change in length, hence the applied force in the form of mass into gravity, and area is nothing but pi r square. Area, the wire length, suppose this is the wire, and due to, if we apply some weight, then the length of that wire is increases. There change in length due to weight of this force in the form of weight. Force in the form of weight, and if we apply the weight on that wire, the wire is length of wire is increases or increase in length, and such trace is called tensile or compressive trace. And tensile trace is equal to force upon area, or this is equal to mg upon pi r square. Again, SI unit and dimension is same as trace. Second type of trace is volume trace. Volume trace, or it is called hydraulic trace. Volume trace or hydraulic trace. Due to applied force, there is change in volume. Change in volume of the given body. Such trace is called volume trace or hydraulic trace. ज्यावेळेस आपण एखाद्या बॉडीवर फोर्स अप्लाय करतो त्यावेळेस त्या बॉडीचं व्हॉल्यूम बदलतं, व्हॉल्यूम चेंज होतं, त्या प्रकारच्या ट्रेसला म्हणायचं व्हॉल्यूम ट्रेस. Therefore व्हॉल्यूम ट्रेस is equal to force per unit area. But according to definition of pressure, P is equal to F upon A, or this gives F is equal to P into A. Therefore PA divided by A cancel, this is equal to P. But volume trace is nothing but change in pressure. Instead of P you can write delta P, and this is called change in pressure. Change in pressure. The volume trace is nothing but force per unit area, and this is equal to pressure, or that pressure, if volume changes, the pressure is also changed. Hence volume trace is denoted or given as change in pressure, and the change in pressure is given as delta P. Now third type of trace is called Saline trace. Saline trace, when we applied the force on given body, then body changes their shape. Body changes shape. Such a trace is called Saline trace. Therefore Saline trace is equal to tangential force upon area. This is equal to F upon A. This is the third type of trace. First is tensile, longitudinal or compressive trace. This trace is relative to change in length. Second is volume trace, or it is also called hydraulic trace. And this trace is relative to change in volume. And third type is called Saline trace, and this trace is relative to change in shape. This is the different types of trace. Now we discuss the different types of strain. Different types of strain. Strain is also three different types. First type is called tensile or longitudinal strain. Tensile or longitudinal strain. Tensile or longitudinal strain is defined as the change in length per unit original length is called tensile or longitudinal strain. Therefore tensile strain is equal to change in length divided by original length. Now this is equal to change in length, suppose delta L, and original length is L. Or sometimes it is written as small l upon capital L. The small l is change in length and capital L is original length. Suppose this is the original length of wire L. If we apply some weight, the length is increases, and this is called the increasing length or change in length. and the ratio of change in length to the original length is called tensile or longitudinal strength. The second type is volume strength. The volume strength is defined as the change in volume. The change in volume per unit original volume. Suppose this is the original volume V. If you apply the pressure on each side, then this is the dV, change in volume. If we apply the pressure, the volume is decreases, and this is the original and this is the change in volume dV, and the volume strength is equal to change in volume divided by original volume. This is called the volume strength. And last type of strength is the Saline strength. Saline strength. In this type, the shape of body is as like a cube. This is the cube, and if you apply the force on one side or top surface of that cube, then this top surface can be displaced at an angle theta due to this external force. Hence, the shape of that cube is changes, and that type of strain is called Saline strain. That is, the Saline strain is defined as there is a displacement, and that displacement is called relative displacement, and the relative displacement of the top surface of that cube is called shear or Saline strain, or therefore Saline strain is equal to, there is change in, this is the displacement, or suppose this displacement is delta L, or changing Saline strain is equal to delta L upon L, or this is nothing but tan theta, and this tan theta is nearly equal to theta, and this is the displacement through some angle, that is shear or Saline strain. Saline strain is given as tan theta, but this tan theta is nearly equal to theta. This is the third type of strain. The trace is also three types, and strain is also three types, and all these three types have no unit and no dimension. The first type is tensile or longitudinal strain. This is related to change in length upon original length. Volume strain, change in volume upon original volume, and this is the change in displacement upon original displacement or displacement through angle, that is tan theta, or tan theta is equal to theta. Hence, all these three quantity have no unit and no dimension. Now we discuss another law of same chapter, that is Hooke's law. The scientist Robert Hooke described the law called Hooke's law. The scientist Robert Hooke observed the two quantity, that is strain and trace. This is the origin. And he plot a graph of trace versus strain. It is observed that at particular limit, trace is directly proportional to strain, and nature of graph is a straight line from origin. Up to certain limit, एका ठराविक लिमिट पर्यंत ट्रेस वाढली तर स्ट्रेंथ सुद्धा वाढते. एका बॉडी मध्ये जर आपण फोर्स अप्लाय केला एखाद्या बॉडी मध्ये तर ट्रेस वाढली तर स्ट्रेंथ सुद्धा वाढते. पण एका ठराविक लिमिट नंतर हे ट्रेस आणि स्ट्रेन एकमेकाला डायरेक्टली प्रोपोर्शनल नसतात. Within elastic limit, the Hooke's suggest that, or Hooke's discuss the quantity or study the quantity trace and strain and plot a graph trace and strain. He observed up to some certain limit trace is directly proportional to strain, and nature of graph is a straight line from origin, and trace divided by strain is equal to constant, and that constant value is called modulus of elasticity. रॉबर्ट हुक ने ट्रेस भागिले स्ट्रेनचा रेशो काढला. तो रेशो कुठल्याही ठिकाणी काढला तर एक कॉन्स्टंट संख्या मिळायची, आणि त्या कॉन्स्टंट संख्येला त्याने नाव दिलं मॉड्युलस ऑफ इलास्टिसिटी. देन द मॉड्युलस ऑफ इलास्टिसिटी इज डिफाइंड ॲज रेशो ऑफ ट्रेस अपॉन स्ट्रेन. मॉड्युलस ऑफ इलास्टिसिटी इज इक्वल टू ट्रेस upon strain. Then he state the statement of Hooke's law. Within elastic limit, the statement of Hooke's law, within elastic limit, trace is directly proportional to strain. This is the simple statement of Hooke's law. The within elastic limit च्या पर्यंत trace is directly proportional to strain, but beyond elastic limit this is not possible, or this is not true. This is true when there is some limit called elastic limit, or within elastic limit the trace is directly proportional to strain, and trace divided by strain is equal to constant, and that constant is called modulus of elasticity. And modulus of elasticity is defined as the ratio of trace to the strain.